Oh, full screen. I think you can.
Yes,
So hello everyone. As for today's presentation, I will tell you something about our training for auditors, and then I will tell you about one of our buildings, some general information, trigger points, creation of IBRO2 EPC, and the results. So our training course, 15 auditors ranging from beginners to experts were provided with online training. We've covered an introduction to IBRO2 EPC, the assistant, the discussion of the 5 steps required to create an IBRO2 EPC. Our course also included the presentation of all the modules in IBRO2 EPC, so the basic one, energy demand, investment cost, indoor environmental quality, and SRI. After the presentation of modules, we prepared a demo of creating a document from scratch. And our entire training session lasted about 4 hours. And from the 15 auditors, we've chosen 10 and also 10 buildings. All of our buildings were multifamily houses in Warsaw. So that's one of our buildings. I think most people living in Middle and Eastern Europe are familiar with those types of buildings. This one is very small for that kind of a building. We also had an example with over 600 flats. So the general building information. So it's a 4-story multifamily building located in Warsaw, in Wesoła district. It was built in 1973 as a modular reinforced concrete structure, and like many similar buildings, it underwent thermal modernization in the early 2000s. For the trigger points for renovation, so first one is thermal comfort. Despite thermal upgradings in the early 2000s, the building is not insulated sufficiently. The second one is energy prices. Inflation and changes in energy prices are affecting the household budget. This year, our electricity bills will be higher 80% than last year, so it's a very important point. Long-term perspective, of course, so changes in technology and increasing European Union requirements for buildings, and also timing. So residents wished for modernization was spread over as many stages as possible because of their renovation fund. So that's the 5 steps from as soon as possible till 2050. And I will shortly go over all the steps. So the first step is changing of a gas boiler and also connecting a new hot water tank to the heating system. So since prices are going up so fast, we had to replace the gas boiler, which was from the beginning of the building, so from 70s. The second step is window replacement and door replacement for 2025. Windows and doors are from 2000, so so they need to be changed in next year. So for 2030s, insulation of the basement ceiling, external insulation, and roof insulation is needed, because as the same for windows and doors, the insulation is also outdated. It's 2024, so it has already 24 years. So we'll be insulating the basement with 12 centimeters, external with 17, and the roof will be 25 centimeters. For 2040, we'll install new radiators, we'll optimize the distribution system, and we will make insulation of heating pipes to prepare for the last step, which is outdoor air water heat pump and installation of photovoltaic system for a comprehensive renovation. So as you can see, this is the investment cost module, where auditor inputs all the data related to the costs of modernization, and also financing that is possible for that building. And as you can see, the energy-related costs are going significantly down. Also, the need for final energy is going from 176 to 50, which is 1/3 of the beginning final energy demand. And you can see the change from gas to the electricity from photovoltaics. So that's the indoor environmental quality value. So the thing that might be surprising is that the value hasn't changed in all the steps, but that's because our starting building was already quite good in terms of the value. Also, the CARP methodology is quite simple, so the building was already insulated in roofs, external, and floor. We haven't changed the ventilation system. We haven't installed shades, and for the lighting, this is something that people living there are doing for themselves, so we can't just tell them they have to use some kind of lighting. But as you can see, the SRI score has increased, and that's because of the optimization of the network and also the installation of air pump. So it's from 14.3 to almost 100, which is a great score for that building. So here are the results in a table. So as you can see, we don't have energy classes, so we only have colors. So the building went from orange to the dark green, which is great. Final energy demand from 176 to 50. Also, of course, CO2 emissions went down, and energy costs are very small, from 113, almost 14 zlotys to 20. So that's great, especially that older people are living in the building, so they don't have big pensions. So SRE rate is also great, where 100 is the highest, so almost 90 is very good. And as for indoor environmental quality, nothing changed because, as I mentioned before, the methodology is quite simple and the building was already in a very good state. So that's for me. Thank you for your attention.
Thank you, Karolina. I think it already becomes obvious that different country conditions also require different renovation measures and different approaches. You also showed us the cost module where also cost savings and financing were mentioned. And there is a question if there is better financing available when the renovation is being carried out in line with IB Road to EPC.
I think currently not, at least in Poland, because to get subsidized, you have to show the energy audit, which has its own details and layout and requirements. But I think IB Road 2 would be ideal for subsidized because it would show which steps the owner is going to take, and also so the company that is giving, or the government that is giving subsidies, can just at the end see if those measures were implemented step by step and control step by step the owner.
Indeed, yes, I understood. Thank you very much. If you stop sharing, I will introduce our next speaker. So Eleftheria is getting ready. Give me one moment to introduce you. Eleftheria Touloupaki is our next speaker, and she is an architect, engineer, Master of Science and PhD candidate, project manager and research associate at INZEB, with extensive academic and professional experience in the design and construction of energy efficient buildings. As a certified C-class energy inspector of buildings in Greece, he has audited over 40,000 square meters in Greece, most of them belonging to the public and tertiary sectors. And Eleftheria, the floor is yours to present your examples from Greece.